All right, section 1.2, we're solving multi-step equations. It's day 2 of this. Our goals are to be able to solve a multi-step equation with one unknown variable on each side of the equation, but also we're going to solve equations that have one or infinite solutions. So real quickly, let's review. The first step, use inverse operations to isolate the variable I've highlighted, because ultimately that's our goal. We're going to use inverse operations to get the variable, whatever the variable is, by itself. And then below here are the steps that we will follow, typically in this order, but we've already seen some examples where sometimes we have to switch up the order depending on how the problem is set up. And then the special cases we talked about, these are going to start showing up in these problems today. So if you're solving an equation and all of the variables completely cancel out, they just don't exist anymore, and you're left with a true statement. So for example, all the x's may cancel out and you're left with something like 7 equals 7. That is an example of infinite solutions. So for instance, if you had something as simple as, well, what if x plus 1 is equal to x plus 1? Well, the left side and the right side of this equation are exactly the same. And if we solved this one, if we subtracted x from both sides in this problem, the x's would cancel and we'd be left with positive 1 equals positive 1, which of course that is true. So that is an example of infinite solutions, when the variables cancel out and you're left with a true statement. Likewise, similar manner, you get no solution when you're solving it and all of the variables cancel out and you're left with a false statement. So for instance, if you get x plus 2 equals x plus 3, and if we subtract x from both sides here, we would end up with positive 2 equals positive 3, which makes no sense. That means that equation has no solution. Most of the time, it's not going to be obvious if it's infinite or no solution until the very end of the problem. So for instance, these examples we're about to work out, that could happen in either one of those examples, but you can't really tell at first glance looking at these. You've got to actually solve and see if everything cancels out and you end up with a true statement or a false statement. So example 1, solve the equation 4g plus 12 plus g equals 3g minus 8. So let's follow these steps. We do not have to worry about the first step because there are no parentheses. The next step says combine like terms on each side independently. So if we look at this expression on the right side, you have 3g minus 8. Those aren't like terms. But on the left-hand side, this expression independently, if we combine those terms, we would end up with 5g plus 12. So that is the second bullet point. We can check that off. We've done that. All right, the next bullet point says move variables to one side using inverse operations. So our variables are 5g and 3g in this problem. So we need to move these to the same side. I'm going to move the smaller of the g's to the left side. So the inverse operation of positive 3g is subtracting 3g from both sides. So when we do this, we end up getting 2g plus 12 equals, let me do my vertical line right down the middle. These 3g's cancel and give us 0, and then we'll drop down the negative 8. I didn't mean completely erase it there, but I did. And now our like terms, we're going to subtract 12 from both sides. And we're going to be left with 2g equals negative 20. And then finally divide both sides by 2. We're left with g equals negative 10. So this one had a clear solution.